we are doing the topic of components of traffic system, and there are 5 components: road users and vehicles and streets and highways, traffic control devices, and general environment. In road users, we discuss 2 main components, which is 2 main parties, which is the drivers and pedestrians. For drivers, the important characteristics are visual acuity, reaction process, and personality and psychology. For pedestrian, the important characteristic for design is their walking speed. Okay, and the same characteristics will apply to any other road user because all of them are obviously human beings, right? In vehicles, we said there are 4 important characteristics: deceleration, which is also called as braking; acceleration; low speed turn; and high speed turn. For low speed turn, we have tables to design the curve because the external forces are negligible. Okay, for high speed turns, we have the equation to calculate the radius, and we have to satisfy the equation. Okay. For braking distance, we looked at the equation for braking distance. Okay, and we did this example as well. Okay. Moving on. So I said we have 5 components, right? 5 components. Okay. How many we have covered? How many we did? 2. Which 4? Driver, pedestrian is 1. Road user. Okay. Move on. Okay. Okay. Anything else? What were we doing before this topic? Which topic we finished before this? Signals, right? So signal is part of what? Road? Signal is part of that entire thing, right? Where we communicate to the drivers? Control devices. Okay, so control device already done. Yes. And yes, in road characteristics, we just some of them. Radius, or even before when we are doing capacity analysis. Capacity of what? Roads, right? So roads and streets, we covered some of it. We will discuss some more about the roads and streets now, highways and streets. Okay, the most important thing from the perspective of safety on the road is how much distance you need for stopping. Okay, the most important element of safety on the road is how much distance you need for stopping. Okay, now why would we stop on the road? Give me an example. A signal, traffic jam. Okay, so now if you see a signal or a traffic jam and you want to stop, so you will do what now? Brake. Okay, so we have an equation for braking distance, right? Braking distance is part of it, right? Agreed? Braking distance is part of stopping. Before you brake, you do what? Think, right? Reaction process, okay? And how do we measure the reaction process in terms of what? Time, okay? So this is the equation for stopping distance. This is the equation for stopping distance. This part is the braking distance, okay? The second ratio is the braking distance. And this is what? S into T, reaction time. Okay, and what is this? 1.47? Conversion. Okay. And one more thing which they have put in the equation, which is 0.348. So just a reminder, 0.348 is the F value. And F is A upon G. Okay. The 0.348 is the value of F when A is standard. 11 point. If A changes, then you cannot keep 0.348. You have to change. Clear? Okay. So in the first equation, you will get the distance in feet. In the second equation, you will get the distance in meters. And you will put the speed as what? Huh? Meter per second? But you said we have conversion factor, right? Kilometer per hour. Okay, where? Down. Okay, because the distance is in meters, so speed should be kilometers per hour, and distance is in feet, the speed is in miles per hour. Clear? Okay, but all the conversions are there. You don't need to do any conversion yourself, just pick the right equation and you put the speed as it is. Clear? Okay. Okay. A driver traveling at 65 miles per hour and he comes around a curve, it's a level grade. Okay. Now, if the grade is not mentioned and they say level, we'll assume 0. Okay. If the grade is not mentioned and they say level, just use the word level, we will assume it is 0. Yes. Yes. This is why I said if the grade is not mentioned and only the word level is mentioned, then we will assume 0. Okay. If they give you the grade, use it. Even if it is 0.1%, use it. Okay. Clear? So when they go around the curve, they see a truck overturned, is fallen on the road, is blocking the road. Okay, so now what are you supposed to do? Stop. The point where he sees the curve, the distance between that point and the curve is 350 feet. Okay, so he looks at the curve and he thinks, okay, this looks very amazing, why is it on the road? And he thinks all these things, and then he starts to brake, and his deceleration rate is 10 feet per square second. Clear? Okay. Now the last sentence is what is scary. Okay, what they are saying? What is they are saying in the last sentence? So he will go and hit the truck. He will go and hit the truck. Okay. So we don't want him to live. He will eventually die. So we will just answer what speed he will die. Okay. So he can be in the martyrs. We say he died with honor at so much speed. Okay. So do I need anything here in this equation? All the values are given, or do I need to change something, calculate something? Everything is here. 0.348 was the F value, and the F value is when you use standard A. The A is given here. Okay. How much is the A? 10. So how much is the F value now? So instead of 0.348, we will use 0.31. Okay. So now what is D? Oh, sorry. Yeah, 350. But what are we trying to calculate? SF, the final speed. Okay. Tell me the final speed. Perception reaction time, the normal value is taken as 2.5. Okay. But there is an entire table. If you go to the previous slides, you will see an entire table where perception reaction time is given according to different situations. Okay. For the time being, just take it 2.5 seconds. Okay. I'll show you another table for perception reaction time as well, but for the time being, 2.5 seconds. Oh my God. You have the slides in front of you. The equation is there in the slides. Wow, from where did I get it? You're just complaining, huh? No matter what. Even he remembers the equation. You just say for the sake of complaint. If this equation is wrong in the exam, you will be the first one to tell me, doctor, this is wrong, right? How much? This is the only answer, huh? It's a second degree, right? That's why I'm asking. You can be two answers. This is positive, negative? Positive.
How does this negative?
Equation. This is what I'm saying, because it's a quadratic equation, you will get two answers. You have to pick one, right? Okay? So if you get a negative answer, you ignore it. Take the positive one. Anyways, but you can see 56.5 miles per hour. At 56.5 miles per hour, he will do what? Crash. Okay? So this is the word they are using now for road accidents, crash. Okay? So after the class, just pray for him. Okay? Now, if I want to avoid this crash, what should we do? Very good. How did you get to this conclusion? Huh? Stop before the crash. Very good. How do I make him stop before the crash? Tell me. Huh? Lower the speed. Yes. Huh? Press the brake harder. Okay. Increase the distance. Okay. All these things are correct. Okay. This is related to the design. I can do this with the design. Okay. Put a sign there or make sure that the speed limit is less and so on and so forth. Okay. This is related to the driver. I cannot control it. I can estimate it. I can have some safety measure there, but I cannot control at what deceleration exactly the driver will decelerate. Okay. Our is higher. The standard value is higher. He is slow. And the second thing which is related to design is that you increase the distance. Which distance? 350 feet. It was 350 feet. What was 350 feet? Distance between what and what? At what time? When he saw the truck. Okay. So this is what we call as the sight distance. Sight means to see and distance is distance. Okay. So sight distance means how much far you can see on the road. Sight distance means how far you can see on the road. The minimum is at any point on the road, you should have enough sight distance to see an object and stop safely without hitting the object, without crashing. Okay, the minimum standard is at all points on the road, you should have enough sight distance so that when you see any object, there is enough distance available for you to stop before hitting the object. Clear? Clear? Okay, so this standard is called as safe stopping sight distance. Okay, when you make the sight distance equal to the distance which he requires for stopping. This is called as safe stopping sight distance. And this should be available on all highways at all times and locations. Clear? So you have a small example here. You can do it yourself. The design speed is given. Use the standard reaction time. If you are talking about stopping sight distance, then your final speed is 0. Okay, and everything else is standard. Okay, so how much sight distance should be available on this road if you want to make it safe for stopping? Clear? Okay, you can do it, right? Any questions? Clear? Okay, this is from the traffic book. Okay, not the textbook, the traffic book which they give you at the time of license. Okay, so you don't read any traffic book, right? Not this one or that one, right? The way you are looking at it. You haven't seen it, right? Huh?
They didn't give us the book.
Now you said they didn't give me the license as well, right?
It wasn't COVID.
Huh?
It wasn't Corona.
It's online.
They didn't tell us that it's online.
Somehow you got the license, right? They don't tell you come and get the license. You go there yourself, right? Find it. Okay. Anyways, that's not my point. The point is, see, for your sake, especially for the boys, they put a football field to show you how much distance you will cover at 100 kilometers per hour when you are, when you are late in reaction and so on and so forth. Okay, just for your sake, so you at least take some interest. Okay, but you don't, obviously. Okay, ignore it. We are still alive. That's what matters, right?
There is airbag.
Huh?
There is airbag.
And there are graveyards as well. Okay. Another example, a driver must slow down from 60 to 40 miles per hour because there is a severe curve ahead of him. So the curve is very sharp, so he needs to reduce his speed. Okay, so I should put what for him? A sign. Okay, a sign, and the sign should be before the curve or after the curve? Before the curve. Okay, so I need to put a sign before the curve. Now they know the design of the sign, how high is it, how big is it, and according to that design, any driver who is eligible for driving can see the sign from at least 120 feet. Okay, the point where the driver can see the sign is at least 120 feet. Okay, now they want to know how much should be the sign before the curve. How in advance should the sign be from the curve? Okay, so we have three things in order. We have the driver, we have the sign, and we have the curve. They are in the same order. Okay, I know the distance between two of them, right? Which two? Sign and the driver. And I want the distance between the other two, the sign and the curve. And I can calculate the distance between what? Driver and the curve. Okay, so I have this equation. I have to go from 60 initial, 40 final. Rest of the values you can take as standard. Reaction time 2.5 seconds, and this remain as it is. Okay, so give me the distance here. How much distance he needs to stop? Oh, sorry, to slow down. Point. Okay, this is the distance between the driver and the curve. Okay, and I have the distance between the driver and the sign. Okay, so I have these 3 points here.
So now subtract the 120 from this value.
Hmm.
We get the distance from the sign to the curve.
Yes. Okay, so I have the driver here. I have the sign here somewhere, and then I have the curve here. Okay, so the distance between sign and the driver is 120 feet, and you just calculate the distance between the driver and the curve. Okay, so I want this distance now, the distance between the curve and the sign. How much is it? Call it D dash. Okay, clear? Any problem? Okay. In both the previous examples, the one with the truck and this one, we took very simple situation. There's a truck on the road is blocked, you will stop, that's it. There's a sign on the curve, only one sign, and the sign says reduce speed 40. So you will slow down to 40. Okay, very simple situations. But life is not simple, traffic is not simple. Okay, so we may have some complex situations on the road. Okay, where the drivers may have many things in front of him. Your friend? Huh? What is he saying? Famous, huh? Okay. So, yeah, so there are complex situations. If there's a complex situation, there have many things to think about. Okay, or you don't know what to do exactly. Okay, it's not like the road is blocked and I have to stop. There's nothing else to do. Okay, there can be complex situations where you may have multiple things to do. Okay, so in those cases, your time to think will be more. Okay, in complex situations, you need more time to think. If the exam is difficult, you need more time to think. Huh? Forget. Very good. Huh? More time to forget. Very good. New one, huh? Okay. So, yeah. So, what are these complex situations? Some examples here, just to give you the idea. Interchanges or intersections, where you may have crossing traffic. Okay, or you may be changing your own lane, or somebody else is changing the lane. Okay, so you are in a traffic which is going across you now. Okay, it's no longer who is in front of me and who is behind me, or what the signal is saying. You have to worry about other things now. Okay, changes in cross sections. Okay, so the road cross section is changing, number of lanes are changing, for example, or gradient is changing, slope is changing, super elevation is changing, shoulder, maybe there was a shoulder, now there is no shoulder, there was a median, now the median is gone, or the other way around. In any case, once you change the cross section of the road, drivers will adjust themselves according to the new conditions. And again, everybody will change, right? So you will have people who are coming from different directions and trying to do something. Okay, so a complex situation. Or areas where you have visual noise. Okay, visual noise means you have too many objects in front of you. So sometimes you come across an area where there is a signal and there are boards to show where the direction is going. Okay, and then you have to worry about the lane marking as well, because each lane is going in a different area. Okay, and which lane should I be in? And there's a pedestrian crossing as well. Okay, so all these things. Okay. If it's a commercial area, then this one is saying 50% off, this one is saying 60% off. You have to decide about these things, right? Very important decisions in life, right? Where can I get more offer, right? So they call it visual noise. When the number of objects in front of you are very high, and each of them is directly in front of you, and many of them are related to traffic. Okay, clear? So in all these cases, you need more time to think. Okay. So for example, I was talking about an interchange, right? Okay, so this is an interchange where a ramp is coming in and the other one is going out. Now you see how many vehicles here? 5 vehicles. Okay. Normally on a busy interchange, you may have hundreds of vehicles at the same time. Okay. Now you can, maybe some of these vehicles are going from here, one ramp to another ramp. Maybe some of them are going from ramp to the highway, some of them from highway to the ramp. You can see it's a zigzag movement and everybody is doing something different. Okay, their speeds are different, somebody is accelerating, somebody is decelerating. Okay, and so on and so forth. So this is a complex situation now. You need to decide, you need more time to think what to do now. Should I be in my lane? Should I slow down? Should I accelerate? And so on and so forth. Clear? Okay, so now let's say in you have a complex situation, and we are considering the worst case, which is the stopping. So driver is faced with a scenario, and in this scenario he will stop. Okay, now do I have an equation for stopping distance? We have. Okay, the equation we have is from the laws of motion. Okay, laws of physics. It will not change. Look at the first part, speed into time. Speed into time equals distance. Whether it is complex or normal, doesn't matter, right? Second part, distance covered in deceleration or braking. Again, we did the whole derivation. It will not change. Okay? So the equation will not change. The equation, I will still use the same equation. But what will I change in this equation? Which value will I change in this equation? Reaction time. The main difference between a normal stopping and a decision side distance is the reaction time. Okay, so although we will use the same equation, but the reaction time will be higher. Clear? Okay. Now I showed you the ramps, right? Ramp going in, coming out. Okay. Should the driver stop there? No, right? You stopping can create an action, can create a crash. Stopping will create a crash. So stopping is unsafe. Okay. So if the location is like this, I know it's a complex location, and I know the driver will not stop. So providing stopping side distance doesn't make any sense, but I don't want the driver to stop. Okay. So in that case, we have another equation to calculate the distance for other actions. Okay. For the time being, to make our life easy, for the time being. Okay. All other actions are with the same equation. Okay. Yesterday I found the new editions of the textbook and the highway capacity manual and so on and so forth. Okay. So nobody knows what will happen next semester. So this is why I'm saying, for the time being, we have only one equation. Okay. So you guys will graduate, no problem. But next semester, don't tell anybody that this happened, that happened. You don't know what will happen. Okay. Especially when I'm going to Pakistan now in summer, nobody knows what will happen. Okay. So we have a single equation to calculate any other action. Other actions, change of lane, change of speed, change of direction, change of path, any other action. Clear? Okay. Now what does this equation have? 1.47 conversion factor. TR, reaction time. TM, maneuver time. TM is maneuver time, the time when you will do your action. So you will think, that is TR. Then you will do, that is TM. Clear? And then we have the speed. Okay, so the first equation will give the distance in feet, the second one will give the distance in meters. Clear? Now these timings have standard values. Okay, so if you take the gradient as 0, you exclude the effect of gradient, and you take everything as standard. Time is a standard. Okay, the f value is standard, everything is standard. Then you can use this table to find out the decision side distance. Okay, based upon the design speed. Okay, so you can see I have the design speed, and then I have what? The maneuver time. Design speed increases, maneuver time decrease. Why? Because now he is doing it faster. He is doing the same thing faster, so he needs less time. Okay. And then we have the reaction time on the top. This value 3 and 9.1. These are the reaction times. Okay. So the reaction time depends upon the situation. Okay. So we have the first two columns. Both of them are for stopping. So we use the equation of stopping distance with these reaction times. The equation is the stopping distance equation, and the time is these ones. Then the next three columns, the other maneuver equation, this equation. Okay, the next three columns are from here. Now if you look at column A and B, we have same action. Okay, what is the difference? Why the reaction time is different? Because of the area. Which one has more time? Which one needs more time? Urban needs more time because it is more populated. We're talking about visual noise, right? Urban areas have more visual noise because they are more populated, more buildings and boards and everything. Clear? Okay. And same thing between C, D and E, the area is changing. Okay, that's why the reaction time is changing. Okay. Then we may have situations where we may have to provide a passing side distance. Okay, passing side distance. So the distance which you should be able to see to make a safe passing. Okay, this is not the distance in which you will do the passing. Distance which you should be able to see to decide whether I should pass and then pass. Clear or not? Okay, because every time you see or you want to pass, you will not pass because you don't have the chance. Get my point? Okay, but to decide safely whether I should pass or not, you should have passing side distance available. Okay, because even if there is no passing side distance, the side distance is not enough, drivers will still do the passing. Okay, but then it's not safe. Okay, so we want him to have enough distance to decide this safely and then do it. Clear? Now if the passing is not available or the distance is not enough, but I said driver will still do it, so what should I do? Airbags, huh? Yes, as a traffic designer, yes. I asked something in the other section, one boy said that we will sell him bumpers. It's cheap. As a traffic designer, yes. Very important question. Yeah, we will ban the passing. Okay, we'll put some marks or sign that you cannot do the passing. Clear? Okay. Now, we have this table. You already have covered the passing side distance in detail in the highway course. You have seen the equation. But again, if you take everything as per standard and there is no gradient, we can use this table as well. Okay. So we have the passing side distance required based upon design speed. Okay. And in passing, we have two vehicles, right? Two vehicles are involved. Okay. The yellow one and the red one. Okay. Red one is mine. Anybody has yellow, don't come in front of me. Okay. So we have the passed vehicle, which is the yellow one, and we have the passing vehicle, which is the red one. Okay. The passing vehicle is going as fast as what? Design speed. Okay. It's going as fast as the design speed. Okay. Can you go more? Yes, obviously. That's why we have the airbags and the hospital and the, right? Okay. If he goes more than the design speed, then he is gone. Okay. So whether he is doing the passing or not, more than design speed is not allowed, obviously. Okay. More than design speed is even not allowed is not possible. He will get into a crash. That's why I said design speed. Okay. So then we have intersection side distance, which is different from all the others. Because in all the others, we are talking about side distance in front of you. The truck was where? In front of you. The sign was where? In front of you. Passing, looking where? I'm looking where? On the front. On intersections, the front is not usually your problem. Your problem is who? The one who is crossing. So I need enough side distance to the sides. Okay, so that's why intersection side distance is calculated in a different way. Clear? Okay. there is one thing which we calculate using the stopping sight distance, which is the yellow time. In the signal design topic, we had an equation to calculate the yellow time. That equation is coming from the stopping distance equation. The equation of yellow time is from the equation of stopping distance. How? So this is your stop line. Okay, at the intersection you have the stop line, and behind that, from the stop line, I calculate how much stopping distance I need, and I mark another line. The distance D is what? How much distance you need to stop at the stop line. Clear? Okay. Now, if a driver is already past the D point, okay, so now the distance between him and the stop line is less than D. Less than D. Okay. So he sees the signal is red now. He decides to stop. Obviously, red signal. He decides to stop. Okay. Where will he stop? Can he stop before the stop line? He cannot. It's not physically possible for him. Okay. So what's the purpose of yellow? Yellow is for this guy who doesn't have enough distance. So we want him to reach the stop line and cross it while looking at a yellow signal. Because if he sees red, he will do something which he shouldn't. Okay? Clear? So we want enough yellow for any driver who doesn't have enough distance to cross while looking at yellow. But we don't want the yellow to be so much. The driver who's coming from 2 kilometers, he sees the yellow and he still thinks I can go. Okay? Yellow is nothing. Okay, got it? So yellow should not be too much or too less. Both things are dangerous. Okay? So we want the yellow to be exactly for a driver who is at the D distance. So he has exactly distance between him and the stop line equal to the stopping distance he needs. So this driver, he will reach the stop line while looking at the signal as yellow. Okay? And most of the time, obviously, he will cross. Okay? And even if he decides to stop, it's enough. He can stop within distance D, right? So he is exactly at distance D and he reaches the stop line, he can stop, no problem. Okay? So yellow time is just enough for him. Anybody who is behind him, the signal should become red before he reaches the stop line, right? Clear? Anybody who is in front of him, he will cross during the yellow. Clear? Clear? Okay. So let us take an example. You can look at this link as well. They have shown a device which they use for yellow time. I already told you about it. So we have a driver who is approaching the intersection at a speed of 40 miles per hour. Okay. How long should be a yellow interval for this driver? Okay. For signals, the standard reaction time is 1 second. The standard reaction time is 1 second. Okay. Now there is, we'll consider gradient to be not there. Okay. Everything else is standard, so you can keep f as 0.348. Okay. And so tell me the distance here. How much distance he needs to stop? 212.1. Okay. Now we want yellow. We want so much yellow that this driver can easily reach the stop line. This driver who is coming at 40 miles per hour and he is at a distance of 212 feet from the signal, he can easily reach the stop line. So how much time he needs to reach the stop line? So he is traveling at 40 miles per hour and he has to cover how much distance? This much, right? Okay, so any driver who is at a distance of 212 feet will see enough yellow at a speed of 40 miles per hour. How much? Okay, so most critical case, the driver who is exactly at distance D, and even this driver will reach the stop line during yellow. Clear? Okay, this is how we got the equation of yellow interval in signal design topic. Okay, any questions? Okay. Now, the most important part about highway design is functional classification. Okay. Now, function means what? Work. Meaning? Performance. Smile. Yes. Function means? The function of bottle is to have water, right? So, use. Use. So the any highway has two uses, two functions. Okay. Accessibility and mobility. The highway has two functions, accessibility and mobility. Okay. Accessibility means connections. How many points or facilities or areas are connected by this highway? And mobility means efficiency of movement. How fast you can move on the highway. Okay. So accessibility is connections and mobility is speed. Okay. And these things are inversely proportional. These two are inversely proportional. If you increase the number of connections, your speed will decrease. Because connection means crossing. Somebody is connected, he will cross you or he will enter on the highway. So this will reduce your speed. Okay. So if you want to maintain more speed, you have to decrease accessibility and vice versa. Clear? So you can see here 4 basic types of highways, freeways, arterials, collectors and local streets, and each one of them has a person through service. The word through in signal design, we use it for straight. Through means straight. Okay. So here through service means how fast you can go straight, keep on going straight without any connection, without any crossing. Okay. A straight movement without any interruption. Okay. So obviously, if you keep on going straight, your speed will be increased. So that means your mobility is more. So person through service is related to mobility. And if mobility is decreasing, that means accessibility is increasing. Okay. So we have the freeway. We already talked about freeways in the capacity topic. So freeway is without any interruption, right? It's uninterrupted. So you can see the through service is full. Okay. And as you go along, the through service is decreasing. That means accessibility is increasing. Okay. Now local streets. So you can see the hierarchy here. We have the freeway connected to the arterial connected to collectors. They are only showing one collector, but arterials can be connected to multiple collectors. But it's an intersection, basically. It's an intersection. So, and then one collector is connected to multiple local streets. Okay. Now you may say each local street has just one connection. No. It has one connection with a collector. But each local street is connecting each house and each shop and each facility in the street. So when you come out of your garage, you are on a local street. Okay. So if I make the houses which are on this local street, each house is a connection. Each house is a connection. Okay. You are coming on the local street from the house. Okay, or from the shop. Okay. So connections are not limited to other highways. Connections are also limited to buildings and facilities. Okay. So local streets are connected to, are your main connection to the last connection to the buildings. Clear? Okay. So that's why it has very high accessibility and very low mobility. Now any trip can have 6 possible stages or phases. Any trip. Okay. These are possible. So we have the main movement, transition, distribution, collection, access and termination. Main movement means what? You take an arterial or a freeway and you go from one city to another city or one area to another area. This is main movement. Okay. Then we have transition. Transition means change. Transition means change. So the point at which you change your service. So you go from a freeway to arterial. So the ramp which you are taking to make this change, that ramp is transition. Okay? Or you are walking and you went to the bus stop, now you take the bus. The bus stop is transition. Got it? Distribution and collection. When you go towards your destination now. So distribution is the highway which will take you towards your destination, and collection is the highway or the road which is inside your destination area. Okay? Clear? The distribution is taking you towards your destination area, and the collection is taking you inside the area. Okay? And access is basically the local street which will take you to your final destination, to the door. Okay? Termination means where the point where you will end your trip. Okay? So your trip will end at a point, maybe a parking space, maybe the door or whatever. That point is termination. Got it? So main movement, area to another area. Transition, change in service. Distribution and collection, now you are going towards your area and inside your area. Access, the last street. And termination, the final point. Clear? But all trips may not have all the stages. All trips may not have all the stages. Okay? For example, you are going towards the mosque for praying. Okay, which is in your street. You will not have main movement and this and this. You will just have access and termination. Got it? But a very long trip can have these 6 possible phases, and different types of highways serve different phases. Okay, like I mentioned, access, the local street. Clear? Any questions? Okay, so we are done with the topics now. We are finishing here. Whatever is left is left. Okay, so we are done now, and you may do the presentations on Thursday. Okay, so in the last week you don't have to see me then. Okay, so if you want to do on Thursday, let me know. Clear? Okay, thank you.